My name is Kavin Raj Kalyanasundram.
My name is Ting. Jing.
My name is Harivindran A. Ramalingam.
My name is Ting.
Thank you for evaluating our project. Coming straight to the point, even in the pandemic time, people are using their hands to scan their temperature and also press out the sanitizer. This is a big threat for spreading the virus tremendously. Thus, we made the decision to create an automatic doorstep sanitizer where it will scan the temperature and sanitize the customer just by sensing their motion.
Okay, so this is our project. Its name is automatic doorstep sanitizer. So the main components that we use IR sensor to detect motion, thermo sensor to detect temperature, buzzer to produce a sound it detects any normal temperature, and a motor control and spray sanitizer. Okay, so now I will introduce some additional feature that we include in this project. So as you can see, there's off display here. So it will show off if there's no motion detected, and it will show on if there's any motion detected. And we also included speed control for the motor. So this is the higher speed, this is the lower speed, and this is the moderate speed, and this is the second highest speed.
So I'll be the demonstrator for our prototype. So imagine the person enters. The thermal sensor and the IR sensor will sense the person. So when the person enters, it will on, and here it now sense off, and it will on also. So the sanitizer will flow to spray the person, and if the thermal sensor sense the person is having a high fever, the buzzer will go off, and the buzzer will sound a bit longer to alert the guards.
So after my teammates have demonstrated how the prototype works, let's go on to the circuit, the internal circuit of this prototype. So this is the circuit that we hide inside the prototype, and I'll show you guys through the schematic in the program later for detailed explanation.
This is the overall design of our auto-sanitizing system. It is basically consists of three parts: the frequency divider, the motor control system, and the 7-segment display system. The frequency divider is used to divide the internal clock of the LTRD2 of 50 MHz into around 2 Hz for the motor control system's D flip-flop clock input. The second part of the system is the motor control system, which includes 4 D flip-flop as the binary shift register. And the power width modulation speed controls are determined from the Boolean expression from the KMAC. The switches are directly assigned to the toggle switch on the LTRD2 board to interact with speed easily. The output of the mux is connected to the motor driver to control the DC water pump. The input of the enabler of the mux comes from the infrared module, which senses the appearance of people. The indicators are assigned to indicate whether the infrared detects people or not. The third part of the system is the 7-segment display system. Note that the 7-segment display of the LDRD2 is active low, which by default all the 7 segments will be turned on. To close it, we invert the input of the expression to get our desired result. The fourth part of the system is the temperature detect system. The thermal sensor output analog signal, which is then compared with the reference voltage. The LED is used in the schematic for easier understanding. It is then replaced with siren in the actual circuit. If the output voltage is lower than the reference voltage, the output will be low. If the output voltage is higher than the reference voltage, the output will be high. The reference voltage was calculated based on desired minimum temperature. In this case, we set it to 37.8 degrees Celsius. This converts the analog signal of thermal sensor into digital signal to the FPGA. That's all from us. Thank you very much.